Hello, everyone. Welcome to the next episode of the Radio Data Podcast. Today, our expert guest is Varun Bhatnagar, who works as an MLOps lead at Swedbank. Varun, welcome to our podcast.
Thank you. Thank you so much, Adam. Thank you for having me here.
Yeah, it's my pleasure. And the main topic of our conversation will be your cloud journey and MLOps at Swedbank. But as always, let's start with the introduction. Could you please tell us more about yourself and your company?
Yes. So my name is Varun Bhatnagar, and I'm working as a lead designer for DevOps and MLOps area in Group Business Intelligence Value Stream at Swedbank. I'm born and brought up in India at a place called Vidisha, which is a very small town. I started my IT career in 2010 as a consultant, working for Ericsson as a Python developer. And this was a time when I started developing a passion towards virtualization, automation, and cloud technologies. And I think that passion gave me a chance to work at Europe's hotbed of innovation, which is Sweden. And I came here in 2014. And since then, I've been helping various customers out with the adaptation of DevOps mindset, implementing CI/CD, and also helping them out with cloud migration journeys. My journey towards MLOps started a few years back, where when I joined the team, I saw data scientists working on their models, developing, exploring, and trying to train a model in a Jupyter notebook, which was developed locally. And after validating the output, the model binaries were getting tossed over the fence to the operation team, and they were then kind of responsible for deploying that into production environment. So it felt like a deja vu. Only this time it was with machine learning and not traditional software engineering. So today, in my current role, I, along with a team of bright engineers, are shaping the state-of-the-art data and analytics platform for Swedbank on cloud.
So, could you please describe more the platform that you're building with your team at Swedbank?
Yeah, sure. So our platform is called Enterprise Analytics Platform, or EAP in short, which is the state-of-the-art advanced analytics platform, which is built to cater to the needs of the whole bank when it comes to advanced analytics and AI. We are set up on cloud, and we are using Azure as our cloud vendor. And we were done with the migration last year, somewhere around June, and we have pulled off the plug on our on-prem setup, and we are now fully operational on cloud. So, as part of migration, we have we did quite a lot of things. So we have migrated over 50 sources, encapsulating around 650 plus tables. We migrated around 95 terabytes of data, and now that data is stored on cloud. We have around 22 plus analytical models fully operational on cloud, and there are lots of other models which are currently being developed as well. We also have integration with various BI tools for reporting and analytics. And we are fully secure, and we are following all the compliance with regulations. And because we are a bank, we have to do that. And we also have automated data governance and control access in place. We also have CI/CD implemented. We are DevOps by design, so we have our automation and CI/CD pipelines running across data, infra, and analytical workloads.
So based on what you said, you have a very mature data platform in the cloud, and you have implemented a number of analytics workflows that work in production, and they serve many business use cases. But let's maybe go back in time and tell us a little bit of history of how you discovered the need for moving to the cloud and building ML platform at Swedbank. And for instance, what challenges you have faced when implementing it. Could you please elaborate a bit on that?
Yeah, sure. So in order to go through that, I will have to take you maybe a few years back, somewhere around 2018 or 2019, or as I like to call it, the Stone Age, where we started experimenting with machine learning in our value stream. We explored this area and we gained relevant knowledge. And we got our very first model deployed into production. And for us, this was a very huge achievement. And this was the very first step towards MLOps. And what happened behind the scenes was that the code was written locally by the data scientist on a laptop. And a lot of hard work went into training and evaluating this model because getting the data and training the model against it was one of the major challenges. We got that sorted somehow. And with the help of some very brilliant infrastructure engineers, we got this model deployed and executed in production. And since everything was done manually, it took us a lot of time to get this model deployed into production. And while we were doing this, we had a lot of learnings. And one of the things that we realized was that while doing this, we lacked integration with bank service. So we realized that we need to have that going forward. The set of people who were involved in this whole process, they were kind of disconnected. They were working in silos, and it took a lot of effort to get everybody onboarded and get this model deployed into production. The next thing which we also realized was that we will need some kind of automation to get this deployed more quickly. So we lacked automation. We also realized that we need to do this in a proper standardized way. And since everything was manual, we wanted to remove this manual process. Data set availability, as I said, was one of the challenges. And we also realized that data is getting copied from one environment to the other, which is taking a lot of time. The second thing was that this is creating data and schema skews because um, there were those issues with data quality, and we wanted to get rid of those. And again, I mean, this was the first model which was getting deployed, so there was no model registry which can track the experimentations the model runs, and there was no way of monitoring the model. So these were these were few of the learnings, and one of the major learnings which we had was that we also realized that machine learning systems cannot be built in an ad hoc manner. Like we will need an automated and streamlined machine learning process, which will not just help the organization to successfully deploy the model in production, but it will also help us in managing the risks as we onboard more and more use cases. So with all of those things in mind, we entered in Bronze Age, which was basically in late 2019 to early 2021 was the span of this, and the focus was really towards streamlining the model lifecycle management. And for that, we started building some frameworks, which will standardize the whole model development process, deployment process. And we did that by integrating open source technologies which were available back then. And with that framework implemented, we had version control in place. We had a semi-automated process of deploying the models into production. And this semi-automated way was a conscious effort because we were still new to this area and we wanted to have more control. Hence, this was a semi-automated process. We also had standardized environment for development and deployment, which basically means that you are having the exact same library software versions, the exact same runtime versions, so that you can avoid configuration drifts. And we also, there were then after that a lot of use cases which we were working with, which we wanted to operationalize, and hence we looked at bootstrapping all those machine learning projects, the repositories, so that they all can look similar. So all of those things which we did here kind of helped us in having a standardized process for model lifecycle management. And it also helped us in shortening the time for model development and deployment to production, at least from how it was in the Stone Age. Although the timing was not ideal, and we realized that there is a scope for improvement there as well. So from this, what our learnings, the learnings that we had here were, because of this semi-automated process, we realized that we have introduced some manual handoffs in between, which eventually led to bottleneck situations and slightly delayed the process. We still had data and schema skews issue. They were not completely removed, but we tried getting them under control a bit from the previous era. Then we there were data availability issues in the sense that the data was only available in production environment. Reason being, there were some compliance requirements that the data in production cannot be copied into the lower environments. So when the data scientists were starting to do the experimentation, or when they were developing the model, actually the data was not completely available to them. So that was slightly a trickier situation back then. And when this happened, the model was running into production. Of course, the production environment, not everybody will be having access to it. So data scientists were slightly flying blind there because they were not being able to see the logs and what the model is doing, how the model is performing. So there was a challenge there. And for model registry, this time we had a slightly temporary solution in place, but we realized that can be improved. So we wanted to work towards that as well. And being on prem, you have exposure to a limited amount of resources, and this was becoming one of the challenges because as we developed more and more use cases, the use cases became a bit more complex, and they were trying to consume more computational power. So, and considering the limited amount of compute resources, there were situations wherein other workloads were queuing up, and they were waiting for their turn to get executed, and eventually they were getting timed out. So we realized that there is a compute crunch with the on-prem setup. And hence, in pursuit of mitigating these challenges that we faced above, we moved into golden age, or as I like to call it, the era of cloud. And this started somewhere in 2021, and it is still ongoing. And some of the key motivating factors because of which we moved into this direction were our on-prem platform was actually approaching end of life, and we were in dilemma whether we should be renewing the licenses or whether we should be investing in a different uh, in a different direction. And we also had a cloud first strategy adopted by the bank because we wanted to be the leaders in this area, and we also saw the increased demands of new capabilities for advanced analytics within the organization itself. So there were these factors which contributed in moving towards cloud. And while we were doing this, we realized that we will have to redesign and re-engineer a lot of processes and ways of working, which we did. And as time progressed, I think the maturity of the platform kept improving. And today we are at a stage wherein we have put an end to our on-prem setup and we are fully functional on cloud. And what we have achieved in this is now we have more collaborative teams. We have different skill sets of people working as one team. So we have broken the silos there. And I think we have the safe transformation, which we should thank because our value stream actually took that route of doing the safe transformation, which helped us in having these different set of people working in one common art to deliver this common goal. We have now a completely hands-off deployment approach. You can still do manual deployments, but that hardly happens. We are doing hands-off deployment. We have automated gate checks, and this automation is right now driven by code changes. We have proper segregation of environments. So we have a separate area for exploratory data analysis. We have separate area wherein the data scientists will do model development. The deployment happens in separate QA and production environments. And the good part about these things is that we have centralized data. Although we have separation of environments, we are not copying data in any of these environments, but rather the data resides centrally. And it's the data governance tool, which is handling the data access in all of these different environments. And because of data being centralized, we have removed the data and schema skews that were happening in the previous setups. We now have a proper model registry in place wherein we are tracking experimental runs, we are tracking the metrics, any model artifacts is getting registered there. As we move into different environments, the model stages are getting transitioned. So we have a proper model registry now in place. We have logging in place. So now the data scientists are not flying blind when the model execution is happening in production, but rather they have a complete visibility of what's happening with the model in each of these environments. Monitoring is something which is partially implemented, and this is something that we are working on at the moment so that this monitoring can help us in detecting when the model is getting stale and when it's time to retrain the model and get this model up to date. So that is something which we are still working on. So with this advancement in technology, we have evolved a solution as well time to time, and we have always uh, have this. We always have this thought process of improving our ways of working as the technology is changing.
It's truly impressive, and I really like your analogy of stone, bronze, and gold age that you used. And it also reminds me a project that I participated in. And this was a project for one of the largest Central European banks. And it was even recently presented at our conference in Warsaw by their director of credit risk. And he described their cloud journey and the ML ops platform in the public cloud during this presentation, and few other topics, of course. And what is interesting, he mentioned that they discovered a few years ago that at a bank they were great at building machine learning models, even very advanced ones. And they were also good at collecting data from various data sources, also very good at aspects such as data governance, data privacy, data compliance. But something that they needed to improve was so-called time to production for their machine learning models. So they set themselves an aspirational goal to increase the speed of development of those machine learning models by 100 times in time to market terms. And their way of achieving this goal was to move to the public cloud and build ML platform using best possible cloud managed and open source technologies. And they successfully achieved this. So I see many similarities between Swedbank and them. However, when they presented their solution at our conference, they mentioned that one game-changing technology for them was Kedro, because it massively improved how they now work at a bank, how their data scientists and different units collaborate, how they break the silos and share the knowledge. So, in your case at Swedbank, is there any game-changing technology that your team has developed, or maybe something else that has changed so significantly the way that your data practitioners work at Swedbank?
Not say just one, but it is actually a mix of slight improvements in each and every area. And as I mentioned, that for us, in order to break the silos, there is this safe transformation that we did, because now the different value streams within the bank, they are doing planning at the same time. And we did there was a bit of restructuring which happened. And because of that restructuring, there are different people from different skill sets. As I said, they are now being part of one release train, and then their focus is on delivering those or meeting those common goals, which everybody is working towards it. And this, I think, kind of has helped us in a bit more collaboration. The collaboration has improved. We now know who's working on what. If there are any dependencies, they are being handshaken, and we now know in which iteration what is coming. So the collaboration between these different teams and different units, for sure, has increased, which has helped us in breaking the silos. Another thing is the architectural changes that we have done. I think that has also helped us in faster iterative development, because we have now, like for instance, this the centralized data part, which I just mentioned, that has helped us a lot, because now we have reduced time in copying the data and making sure that your data is available. And we are not talking about MBs of data. It's huge data that needs to get copied into these different environments, which was happening in the previous setups. So that has also helped in reducing the time to market. Another thing is now that the teams are the teams have a very clear goal as to what they want to achieve, and by which iteration they want to finish off their work. Maybe they want to They want to source the data, for instance, maybe in by iteration one and by iteration two, the exploration should start. So we have very clear goals now, which is also contributing to these faster and iterative way of development.
Yes, yes. And regarding the faster and iterative way of the development of machine learning models, they also mentioned that now they can iterate on each machine learning model in the cloud in much faster and in more frequent way. So that they can optimize their parameters, try new versions of the model, experiment, include or exclude features used by a given model, discover that the model is no longer working so well and it needs to be retrained. So at the end of the day, this allows them to actually build better models and maintain them in a better way. And this, of course, generates better financial results, or it can reduce the risks that as a bank they are taking, or this can also improve the customer satisfaction depending on what the model should do. And having this said, all models that they migrated from on-premise to the cloud, they told that they perform better in the cloud than before on-premise, thanks to the fact that now they can simply leverage the cloud, work on them in more efficient way, experiment, and so on. And is it also your case at Swedbank? Are your model that also work in the cloud now performing better than on-premise?
Yes, of course. I mean, there is with this transformation towards cloud. I think that the performance increases because, uh, I mean, you're coming from a setup where you have seen things uh, which are working, not working. So while you're doing all of these uh, sort of retrospective of when you retrospect all of these things, you kind of see what your pain points are, and then you start working towards it. So for us, in order to have this proper um, implementation of proper MLOps in place, we also listed down few of the pain points, and we have like uh, finalized around 6 components which are must have for your whole MLOps process. For instance, we wanted to have versioning in place. So versioning of your source code, your experimentation tracking, your artifact tracking, ensuring that whatever your configurations are for maybe development environment, it has to be exactly same for your test, your QA, your prod, so that you're not having configuration drifts. For instance, you need to have your testing in place. So you might maybe start with basic linting, ensuring that your repository structure for your ML projects are the same. You then might want to have unit tests in place, and unit tests also in a way that you would like to catch as much errors as possible in your unit tests, and maybe leave lesser things for your integration test, because then it takes a lot of time, which will then eventually if you're finding more errors in your integration test, then you are increasing your development time, because you are catching errors later in the time. So another thing is the automation part. So with all of this cloud technology, you have like integration of different services is made very easier for your whole work to fall in place. For instance, if you're using Azure, you have a seamless integration between your Azure DevOps, Azure repos, and the different services that you are building upon. So that helps in having faster iterative development. Then another component that we see is reproducibility. So you need to have model reproducibility. You do not need to have configuration drifts. You should have similar library versions, runtime versions. You're not spending a lot of time in setting all these things up. These things are there for you, which are made available by your cloud provider. All you are doing is just configuring maybe your runtime versions, your cluster policies, and if you have implemented these things in a right way, you will not be spending a lot of time in setting these things up from scratch for each and every use case, or when your model changes the environment. Similar thing goes for your model orchestration as well, because you might be wanting your workloads to run in a frequent manner, uh, depending on what the use case demands. There is another thing which about monitoring aspect as well, which we see as the sixth component, which is basically you are detecting model staleness, you are detecting if your model performance is up to the mark or not. So all of these things are actually coming out of the box for you. You're not reinventing the wheel. You're not investing your time in developing all of these solutions from scratch, but rather your cloud provider is already having those things integrated in different services in some shape or form. So that kind of helps. And if you have a seamless, well-defined ways of working processes in place, I think it gets a bit easier, which then in the longer run generates more business value, and helps you in more efficient ways of working. And then of course, with all of these things configured rightly, you will have better performance for your use cases.
So, given the fact that your cloud journey at Swedbank is so successful, I assume that you will continue this journey and you will adapt new technologies and you will include feedback from your users in your roadmap and you will add new capabilities to your data and ML platform. So could you please describe what is your focus this year and how you would like to continue development of your platform and what new features and capabilities you are going to add to it?
Sure. So I mean, we understand that the DevOps and MLOps concepts are developed over time, and now that we have a stable and compliant platform up and running, we plan to work on adding more and more capabilities that will generate more business values, and that will help customers to meet their needs. So our focus areas are mainly one of the key focus area is uh, uh, to make this available to as much users as possible. And for that, we understand that we need to have a strong training and support area ready for this to be made available to all the users, so that when they are getting onboarded, they feel comfortable. They know, or they know what is coming, how they have to work with certain services. They need to understand the ways of working. So we plan to polish our training and support modules that we have, so that we find the right balance between the cost and the performance, so that the resources on the cloud can be used in a much more efficient way. The second focus area is the model lifecycle management, wherein we want to increase the automation as much as we can. And the way with the evolution in technology and the cloud vendors rolling out new features every month, I think we want to keep up to we want to keep up with that, and we want to keep on rolling out the best practices. We want to add more and more capabilities. For instance, right now we are working on having this feedback loop completed, wherein we are working with model monitoring, detecting the staleness of the model, and if any thresholds are breached, we want to retrain this model and make sure that the users are notified, and the newer model makes its way into production. So those kind of things are something which we are right now focusing and working on. Another aspect that we are focusing on is the security and governance area, wherein I think, in my opinion, being a bank, this will be a never-ending work. So because we will have to keep on updating our security frameworks, the lineage tracking, we have to keep up with the security norms. So that is another area which we are targeting and which we are completely continuously working on. The another thing which we are focusing on is the accelerator part, is what we call it, which basically means that we are trying to create reusable assets for the users, wherein when they are getting onboarded, they are not reinventing the wheel, and whatever is available, they can just come and make use of it. So those are few things that we are focusing on this year.
Yeah, it looks really amazing. Many new capabilities, many new functionalities that you will add to your data and ML platform to make it even better and better, especially for your users at Swedbank. And we actually haven't yet talked much about specific technologies. So could you please also describe your tech stack and share what technologies you're using?
For our basic cloud setup, I think we have, I think I've already mentioned, we are set up on Azure. For any of the compute workloads, we are making use of Databricks. We are heavily using that. When it comes to version control and CI/CD and DevOps, we use Azure DevOps. And we do not make use of all the services of Azure DevOps because we already have few services set up in the bank. So we have only picked and chosen the services which we really need for integrating the source code to different services. And for access control, at the moment we are using Immuta as our tool. And for orchestration, at the moment we are vouching on the Azure Data Factory. And for sourcing, we use Ab Initio as one of our ETL tools.
And do you also use any open source technologies?
Well, yeah, open source. We make use of Docker and Kubernetes, but I mean those are again coming from the cloud vendor. Like there are different services which they have like molded into the cloud as one of their cloud services. So yeah, I mean we are making use of that, but then they are again branded as Azure services.
Yeah, so probably Spark or MLflow.
Yeah, I mean, when we are making use of Databricks, they, as I said, they are again coming integrated with the product itself. So yes, we make use of MLflow, and yes, for machine learning models we use Spark.
Yeah, so we talked briefly about this earlier, but because the mission of this podcast is knowledge sharing, I would like to ask this question. So please imagine that you would do this cloud journey one more time, and you would need to build data and ML platforms again. So what would be the lessons learned or the things that you would like to avoid or even mistakes that you wouldn't like to make again? Any like important things that you would prioritize to make such a project even more successful? So could you please tell more about that and share your thoughts?
The very first thing that I will do is break the silos, because I think that is very much required considering the uh, different set of people that you will need in order to make this whole journey a success. You cannot afford to have people working in silos. The next thing is very obvious one, but I think we tend to miss the obvious things, which is basically maybe having a clear vision as to what you want to achieve. And as you on your way nail down some of the milestones you might have to revisit and see whether you are on track or not, and then maybe have more and more milestones as you go ahead. Another thing which I will maybe avoid is not try to reach to the whole MLOps journey in one go, but rather I would divide this in a phase-wise approach as we did uh, for this journey. So I will not try to reach the nirvana of MLOps in just one step, but I would rather go for quick wins, phase-wise
Mhm.
approach. And as we build more and more mature mature platform, more and more mature capabilities, we then look on to the next one and get that integrated in the platform. Um, another another thing maybe is um, I mean there is no, in my opinion, single recipe for MLOps to work. In my opinion, you will have to define your own processes and ways of working because you are the owners of it. You know your system better. So I mean, yes, there are articles, white papers, books available which you can refer to, but they shouldn't be the only driving factor. I think you should be, I mean, not going by the book, but rather understanding your processes and ways of working in a much better way, and then trying to apply those things into your architecture and see what fits, what doesn't fit.
Yes, those are fantastic recommendations and great lessons learned based on your experience. Thanks a lot for sharing them. And when asking these questions, you gave a number of concrete suggestions, but you also mentioned that everyone should define own processes and ways of working because everyone knows his or her company better and systems and its culture. So, before we finish our podcast, could you please tell us more about your processes, operating models, and the way of working at Swedbank?
Sure. So we knew that moving to cloud as is will not solve our problems magically. And we knew that we will have to re-engineer and redesign few of our processes and ways of working. So as a first step, we listed down the pain points from our previous setups and solutions and the current needs of the organization. So we made a list of that and we started categorizing them. And we got three major categories after that. So one was the operating model, which basically aimed at breaking silos and creating more collaborative teams so that the work can flow in a more smoother manner. And the second is having processes and ways of working defined, which fits the ecosystem. And then the third is the capability and technology mapping. So, which basically means that based on the requirements uh, we we draw the capability map and then we try and see which technology fits into those capabilities. So um, if we go into more details for operating model, maybe then the main goal while we were creating an operating model was uh, to generate business value from the analytics to the bank and to the customers, which can maybe promote the standardization for code and processes, which will help in shortening the time to market for analytical deliveries. And that will eventually lead to faster iterative development. So, with that thought in mind, we started creating team structure, and that team structure had an epic owner. It had core team, which was containing of product manager, product owner, scrum master, architects, and risk manager. It also had what we call pods. So and there were three different pods which we created, and those pods were having their own responsibilities uh, which they were supposed to carry. So we had infrastructure pod, which was responsible for setting up a stable and functional platform. And there was application enabler pod, which was having a mix of data scientists and ML engineers who were responsible for developing a solution for model lifecycle management. And then we also had as last pod, which was the data and IO pod, which was mainly responsible for data acquisition from new sources, ensuring that the data is available, ensuring that the data governance is in place and data access policies are being put on. So that was the responsibility of the data and IO pod, and this is how the whole operating model for us looked like. The next thing was, as I mentioned, we started working on having our own processes and ways of working. And in order to be more reasonable and to measure the success criteria, we introduced a phase-wise approach. And here the first phase was the solution and design phase. And this phase was again divided into two more phases, which was phase one, solution design phase one, and solution design phase two. And this phase was completely focused on evaluating the capabilities of the machine learning and AI on Azure. So in phase one, it was very theoretical, and it was strictly time bound, which was a 6 to 8 weeks affair wherein we defined the scope and we did high level designs and activities. And the phase two was mainly aimed at transforming the theoretical knowledge that we gained in phase one into more practicality. So what we did was to be more reasonable, we picked up a non-critical use case and we started. The focus was to evaluate the capabilities of AI, do some feasibility studies around this use case, and see what value we are able to generate. And the focus was to create reusable assets and not to do dirty POCs, because we knew that whatever we do from solution and design phase will be the base for us to work for other phases. So with that in mind, we started this migration and implementation phase, uh, wherein we defined our migration strategy. And from the previous phase, we had clear plan as to what parts of the solution we will have to lift and shift, and what parts of the solution will need re-engineering. And because of the work that went into the solution and design phase, we had a clear time plan, and we started our implementation work. And the focus was in this phase to implement the features that we had on-prem. And that was one of the KPIs that we set in order to measure the success criteria of migration and implementation phase for EAP. And hence, in this phase, we implemented the frameworks for model lifecycle management, the modeling, the model versioning, automated stage transitioning, scheduling of models. So those were the few success criteria which were defined for migration and implementation phase. And then the last was the enhancement phase. And this is the phase where we are in at the moment. And after spending like, I don't know, 18, 19 months on both S&D and migration phase, we have now embarked upon a journey of enhancement phase, where we plan to improve upon the existing features and capabilities of the solution, and also adding up new features to cater to the needs of the whole organization. And in this phase, what we plan to do is have enhanced features and add more features, such as I said, model monitoring is one such feature where we are working on. We are also working on features like data versioning and model reproducibility and whatnot. So that is something which we have planned for enhancement phase. So this was typically the mindset that we had while we were doing this, and the decisions that we made, they typically worked out fine for us. The next thing was again the capability map, which I was talking about. And what we did was before finalizing any tech stack, we started jotting down the capabilities, and for this we needed a feedback from the users as well, because they will be the ones using it. So we were constantly in touch with the users, and we also looked at the needs of the organization, and also we had a lot of internal discussions as well as to what are the functionalities and capabilities that we would like to see on the platform. And with all those discussions, we had a huge list of functionalities that we would like to have on the platform. And what sorry and the capabilities or functionalities like having reusable model pipelines, CI/CD, capability of training a model, evaluating a model, having environment separation, code versioning, and all of those things. So these are few examples of those capabilities. And after having that capability map, what we did was we started defining the maturity level of each of these capabilities, starting from absent to low to high. And this eventually gave us a future roadmap to work on. So it gets a bit more easier when you have things in a structurized manner. And with these capability with this capability map, it gets a bit more easier to plan the backlog activity based on what features your customer or the stakeholders are asking for, and then what do you want to see, and that kind of gives you a good backlog to work on.
Yes, it's really systematic and very well structured approach. And what is the most important, it actually worked for you because you delivered a very advanced data and ML platform in the cloud in a very efficient way. And now your platform is used in production use cases at Swedbank, and you still have a number of great ideas how to iteratively add new capabilities to this platform in the short term and also in long term.
Yep, absolutely.
So I will be very excited to talk to you again in the future to learn how your platform is evolving and how you adapt it to new requirements, new priorities, new feedback, especially given the fact that the world and macroeconomy change so fast and new regulations are being introduced, especially in the banking and finance sectors. And of course, banks need to respond to them and adapt their solutions, including data and MLOps platform, so that they can stay innovative.
Oh yeah, absolutely. It would be fun to connect again for sure.
Having this said, I would like to thank you for this conversation, for sharing your knowledge and experience with us, and hopefully the recommendations, tips, advices that you shared with us will be also helpful to other companies that are moving to the cloud or building their data and ML platforms there.
Yeah, hopefully. Thank you so much, Adam, for having me. It was really fun. Thank you.
Thank you very much.